Swayam Prabha. Digital India. Educated India.
Demonstration on ProTherm is thermodynamic database for proteins and mutants. As we discussed earlier, ProTherm contains information on sequence and structure information, experimental conditions, thermodynamic data as well as literature information for different proteins as well as their mutants. The major aspect of ProTherm is thermodynamic data and supplemented with all the other information. You can access ProTherm in this website abram.net ProTherm and explain the utilities and how to retrieve data from ProTherm. This is the website for ProTherm. So, here you can see the links with other databases like ProNet or Biomolecules Gallery. On the left side you can see the major aspects of ProTherm. You can see the overview. So, what the major contents of this database and what we can obtain from this database, and here we update what is new and the statistics page. Here we give few tutorials. So, here you can see the details how to obtain data or how to retrieve data from ProTherm database, and here we can give the more details about the ProTherm, right. So, now here is a cross references. You can see the PDB mapped to the ProTherm and SysPro to ProTherm and so on. And here we give the references. This is the major references and the citations. Currently, if you look at the different versions of these papers and website, it crossed more than 1000, right. So, now if you go to the main page, right. So, if you, this is the simple search. You can give any keywords to search ProTherm. For example, if you are interested in lysozyme, this is the protein widely studied. Okay, and if you click go, so automatically you can give all the data regarding lysozyme. So, these are the entry number, here this is a protein name and these thermodynamic parameters, right. This is the conditions and which measurement they use to get the data and the method, whether it is thermal or the denaturant, and here you get the complete reference, right. So, now if you are specifically interested on any type of data, then you go to advanced search. Right. Here we have lot of options available to search. You can search with any entry. This is the ProTherm entry. So, that is only specific to ProTherm, right. If you have any queries on any data, then you can contact the developers using the entry number. It is easy to check the data. So, you can also search with the PDB code, right. Then you can use the protein name as the source. And if you know the size of the protein, for example, if you have the data on the similar size of proteins, for example, 100 amino acid residues, you can give the molecular weight and you can give the mutation. For example, if you want to see the mutation in, from leucine to alanine, okay, so you can give this leucine alanine, what will happen to mutate this one, and here you can choose whether a single mutation or double mutation or the multiple mutations. If it is single mutation and if you start, right, you will get all the leucine to alanine mutations, right. So, here we will get the experimental data. I will explain the details how to get this all this data. Then you can search with any secondary structure if the mutation falls at helix or sheet or turn or coil, and also locations based on the accessibility. You can use either buried or partially buried or exposed. These are predefined. If you are specifically interested on any specific range of acceptable surface area, you can use here. For example, 0 to 20 angstrom square or 0 to 30 percentage, right, give the values both in percentage, right, and angstrom square, right. Which unit you get using DSSP? You get ICN angstrom square. How to get the percentage values? You divide with the extended accessibility and give the percentage. Now, you can choose any of these options, either the directly from the DSSP results, or you can use the percentage, you can normalize with the extended accessibility. Then we get the measures whether you use a CD or DSC or fluorescence, these are the major measurements, and the methods whether this is thermal or the denaturant, right. For example, if you use the data for the thermal, right, you will get the thermal denaturation, and the denaturant, right, if it is thermal means you will get the data for the delta Tm, right, and this is the data of the denaturant. So, this way it is completely null. So, if you want to get the denaturant, then you will click on denaturant, you will get the data with the denaturation. These are conditions, so pH, and for the denaturant you need to give the temperature, right, you can decide temperature, and also you can search with the different ranges of these experimental data. For example, if you are interested in the very extreme stability, for example, extremely stabilized or extremely destabilized, right. In this case you can give the delta G values as more than minus 10 kilocalorie per mole, and you can see the any mutations which are extremely stable or unstable. See delta G H2O, right. For example, you can use it minus 5, right. Then if you see this, okay, there are some cases, okay, this is minus 5 to any number. So, this is what we get the, okay, I will show this delta G H2O, right. And this is the okay, the reason is why we choose this, what is that? Because we get less number of data, because we put the thermal denaturant, so, right, because we do not get the data with this delta G H2O, only some mutations are matching, this is the reason. If you take this out, okay, and if you get the delta G is more than 5, okay, because in the ProTherm we give the positive sign for stabilizing and negative sign for the destabilizing. So, if it is more than 5, so you can see now the data will be interesting. So, you can see this delta G H2O, you can see these are the mutations, not many mutations, but still 32 mutations which are extremely stable, right. So, in this particular tryptophan synthase and alpha subunit at E49I, if you mutated this increases stability of 8 kilocalorie per mole, right. So, this is very high, right. You can see why this happens, not for all the mutants, we can see several specific mutations which are highly stabilizing. But if we take the highly destabilizing mutants, okay, for example, if it is up to minus 5, right, this is minus 100. This is for example, just because we need the complete destabilizing ones, right. If you click on that, then you can see several mutations which are having highly destabilizing. Now, you can take these type of mutations and see why these mutations are extremely stable or extremely unstable. So, you can do the analysis and you can see whether you can have any common features which you can explain the highly stable or highly unstable mutants and so on. Right, you can use these options to check the extremely stable as well as extremely destable mutants. This is states, as we discussed earlier, 2 state means we have the unfolded state and the folded state, and if you intermediate states, then you can see 3 or 4. Right, you can choose these any states to get your data. Then you can get reversibility, right. You can native to unfolded state, and then you can return back to unfolded to native state. This is reversibility, yes. If not, this reversibility is no, right. Like these keywords, right. So, you can search with any of the keywords as well as the others, right, and the years, right. So, you can do that. So, now we have so many options to search your data, right. Now, if you display everything, there is a big mess, we do not know what you are searching for and which information do you want. So, in this case we have a display option, right. So, you can choose any of these options do you want, right. I will explain some of the some examples. Then we have sorting, you can have sorting options. So, you can sort your data based on the results. The number of entries, the default value is 300, but you can use the more number of 3000 or 30,000 these entries. So, that you can download all the data altogether. Okay, now I go with these few examples. So, let us see I want to have the stability values for all the single mutants, right. So, what to do? we got a single mutation, right, very simple, right. And if you click start, it is a big mess, you need all these things, right. So, now the question is, among all the information, which data you are interested in. For example, if you are interested in the stability data, because that is the important aspect of this ProTherm database. So, you want thermodynamic data. Okay, so, now the display option you just clear off everything, right. So, if you click on the delta delta G H2O, right, this is the change in the free energy obtained by denaturant. So, if you do so, you have to make sure that you should not click the thermal here. If you click the thermal and if you do the delta delta G H2O, you do not get any data, right. If you denaturant, that is fine. If you do the thermal, then you have to look for the delta Tm or the delta delta G, not with the H2O, right, to make sure. Okay, if you do like this, right, if you start like this, what will happen? You get this data. Now, the problem is you get the data, but you do not know this data corresponds to what, right. So, this is not enough, not sufficient. So, what are the important information necessary for the analysis? What information necessary? You know, protein name, right, or if you are interested in the structures, then we need the PDB wild, then it will tell you whether the mutant has the structure or not, right. Then you can make the analysis. If structure is known, you can use structure information. If structure is not known, you can do sequence information. Then what other information do you need? Yeah, this is very important, right, otherwise we do not know, right. Mutation information is very important, that will tell you okay, which residue is mutated to which residue in which protein, right. This is fine. And anything else do you want? Delta G, if you talk about the denaturant, right, if you are interested in denaturation, the delta G we do not get any data. So, you get the delta G H2O, right. So, delta G H2O we had, then okay, we can also think about your conditions, right, because the data varies from different conditions. So, you can use the T temperature, we get denaturant, right. Okay, I can also click here if you are interested in denaturant, right. Then you can see the pH, is pH, right. Okay, let us see what's happening here. So, I got the data like this. This is compatible because it is not exceeding the page limit and all, right. So, you can see this the protein name, this is the PDB ID, okay, almost all the mutants they have the wild type ID. If you want to have the mutant ID, they have to click on mutant ID, then we know that structures of the wild type and mutant, then you can do the comparative analysis, right. Okay, this is secondary structure, right, of these proteins. If you want to have any analysis based on secondary structures, you can extract, right. We discussed about awk, just you can save it and using a single awk command you can get the secondary information, right. Then in this case also if you see there are many null data, you can either remove using awk command, otherwise in the database also you can eliminate this. How to eliminate this? Right, you go to the search option, go delta delta G H2O, you should get some numbers. So, you can give two extreme values. Okay, so, for example, you can give minus 100 to plus 100. Okay. So, M and CM at the moment we run click that. So, in this case if you see this, you see delta delta G H2O, you get the numbers, right. You can eliminate all the null values. So, if you want to remove the null values, you can give some range, then in this case it automatically eliminated because it will show only if you get the numbers, right. So, now you get the some of the data, right. Now, if you see this, right, some cases the same mutant appears several times, that will be difficult to search with this one. So, in this case you can use the sorting option. Okay. So, if you see this one, the sorting option, if you do with this wild type residue and the mutant residue and the residue number, okay, then you can also use the values because delta G H2O you are now using on. So, delta G H2O, then you will see same mutation, maybe same protein or different protein and different locations, how it will change, right. You can see that either you can do the ascending order or the descending order, right. Maybe it is a descending order, that is better because we get the stabilizing ones first, right. So, we start, Oh, it is interesting, you can see the delta okay, this is the because of this descending order we get this y here, right. So, in this if you put the ascending order, let us see what will happen. Okay. So, here if you see the same mutations A to C, right, because alanine is the first one, then you put C, right. So, say different one is Barnes and the stop nucleus, fatty acid binding protein. Here this is the same data, these two A104C, 104C, same protein, maybe different conditions. This way secondary structure, right, you can see these values are different. This 1.51 and 1 because pH is different, 9.6, this 1.2, right. Also you can see this A132E, so you can see the difference in values minus 8.5 to minus 5.8. Okay, this is a major difference. It is depend upon the different pH, the effect of pH. So, if you have the delta G values for same mutation from different pH, then you can do the analysis what is the effect of pH on this particular mutation. If you can generalize for the different proteins, then we can make an analysis, okay, this is the case for the generally for different proteins. You can do the analysis and see whether you can generalize or you cannot generalize depending upon the protein or not, right. So, now if you see this, okay, you can see the displays more than 300, right. In this case if you want to change it, right, here you can increase the number, and if you start, it takes a time because we need to note everything, but it is not so slow. So, you can get the it is more because already it is displayed 1 to 3000. So, you have more number of data and you can increase the numbers and do that. Okay. So, now in this case if you are interested more details on the first mutation Barnes, here we do not have any information. So, what to do in this case? In the display option you also click on the reference, right, and if you are interested in the mutant structures, then you click on PDB mutant also, right. Then if you go to start, right, then okay, we will reduce this number. No, this number is not necessary, right. So, you reduce to 300. So, you will see this is the reference, right, and some of the cases PDB mutant is mostly not available. If it is lysozyme, you can get the mutant data. Here it is, nothing is not displayed. Okay, here you can see the mutant structure, right. If you click on this, on E6L, on E6K, this is a PDB ID. So, you can see this is the mutant one, right. So, you can see this, right. So, you can see this is the wild type and this is a mutation, and you can see this one. So, if you want to get the complete information, you will go to the PubMed, right. So, in the biochemistry paper, if you see the PubMed, you can access the abstract, and if you have access, then you can see the full text, right. Then you can get all this information, right. Fine, right. So, now if you want to have multiple choices, for example, if you are interested only on the buried mutations and in sheet and obtained with the thermal denaturation, right, then you better to select the DTM, that is the range is minus 100 plus 100 degree C, right. You can see centigrade or Kelvin. Here also you can use kilocal or kilojoule. So, whatever. So, what is the conversion between kilocal and kilojoule? Right, 1 kilocalorie equal to 4.18 kilojoule, right. So, you can see the number. So, if you do like this, right, reversibility take S, okay, this is a commonly used one, take two state values, right. Then if you do like this, and here we need to change because okay, already it is because thermally automatically it put the Tm and the T is marked. Okay, CTM we do not need, and measure method we reduce it, reversibility is yes, right, the reference fine, and M we do not need, delta G we need, and this we remove it, and if you source we take, okay, start. Oh, right. So, delta is delta G, did I use this? Yes, is thermal, because I need delta delta G, this I no need. Yes, yeah, delta G, you get the delta G values, right, for the thermal denaturations. Right. So, you can use this information for the further analysis as well as for the prediction, right. So, likewise you can the ProTherm you can use to get in data, because it contains, if you take the statistics, so it contains about 25,000 entries, right. Unfortunately, current there is no current updates available in the ProTherm, but even then the available number of data are sufficient for the analysis. Right. So, it is 740 unique proteins, right, and the about 311 proteins contain the mutants, and these are the statistics for the proteins, and if you these are list of protein names. So, you can have the list of protein names and the source names and so on. Okay, then if you go to the frequency, right, you can see the frequency table. I showed this earlier. So, you can see the some mutations are highly preferred, because the experimentalists they do not want to spend the money for any unwanted mutant. So, they like to have some specific mutations to understand what will happen with that particular mutation. This is why if you see many mutations to alanine to understand the effect of this side chain, right. Right. So, likewise you can get the statistics, right. Now, if you go to the tutorial, right. So, here this so here we gave 4 different questions. First question is search the data for single mutation in helical segments obtained by thermal denaturation experiments. What to do with this? What are the search options you need to use? Right. We need the, because the question is helical segments. So, we need to click on helical and the single mutation, and you can click on the single mutation, right, and the accessibility does not matter, because we are not interested in, we take anything, and the pH 7. So, you have put the pH 7 to 7. Thermal denaturation, so we put thermal. If you do like this, right, then accordingly we click the display option, then we start this, then finally we get the data, right. It is simple. The first one, and go the second one. This is with the denaturation. Here we have the buried region. Buried means you have to get the accessibility buried, right, and then you can see the urea denaturation. So, you put the urea, and the CD measurement, you put the CD, and the temperature between 15 and 25 degrees. So, see the temperature, and if you sort out by temperature and residue number. So, in this case sorting you need to change temperature residue number, right, and if you start, and you will get the data, right. This is the one for these things, right. Then I will take one more example. So, for example, reversible mutation and aspartic acid to any other residues. So, wild type residue is aspartic acid. Now, here is aspartic acid is here, okay, D, to any other residue. So, in this case I put blank, right. Then we use the other conditions, accessibility and the year of publication between 96 to 99, right. So, if you use all these things 96 to 99, and you will get the complete data, right. So, you have various options in ProTherm, and you can use the multiple combination of different options to get your information. Fine. So, we use various terms, right. So, what is the meaning of accessibility, and for example, I put the buried and partially buried and exposed. What is the meaning of exposed? Accessible surface is very high, it is outside the protein. So, what is the range we use for exposed? We do not know, right. So, in this case if you go here, this will tell you, okay, what are the conditions we use for this database, because we can use different cutoff values for the buried or partially buried or exposed. In this case we use less than 20% buried, that is very wide, and 20 to 50 as partially buried, and more than 50 as exposed. If you want to restrict this 20% as 5%, what will you do? Can we get the data, because here the buried we define as 0 to 20%. If you are interested to get 0 to 5, can we get the data? Yes, right. So, here you can define, instead of buried you have to give the values 0 to 5 or 0 to whatever you like. So, then you will also get the data, right. So, here the help page you can get the information for all the technical terms, right, we are used in the ProTherm database. So, you can see all the technical terms, and all the terms you have the complete information. In this case, we can understand more about the terms used in the ProTherm database. Right. So, what are the applications of ProTherm? So, for what we use ProTherm? There is no recent updates, but if you go to the references, okay, reference if you see, so the various applications, okay, these are the database papers, and we can do the analysis and prediction. We can collect the data and we can analyze the stability data obtained from the denaturant or thermal denaturation with respect to accessibility surface area or the pH or the experimental conditions or the secondary structures, and we can see how the stability varies, what happened to stability in different secondary structures, right. We can do the analysis. When we do the analysis, then we can also predict. We can develop several models, regression models or the machine learning techniques, right, or the knowledge based predictions or the decision tree models. We can use various models to predict the stability upon mutation. Then we can also get some verify with the experimental data. For example, if there are some prediction methods, they predict some data. Okay, these are the various citations. Currently, we are not updated. It is okay. So then it is used to cross link with other databases, because ProTherm is linked to the PDB and also various other databases, because we have more than 25,000 data. So, these are the various Metaprod, IndieDB and the ProNet, SRIDE, PGDB, all these databases they linked this ProTherm database. So, we have the structural information and we can related with the thermodynamics. So, we can see to understand the structure stability information with the function and the diseases. In this case, this database is very useful. So, there are various databases. Then Gini methods, so for example, they can predict or they can explain some reasons for any mutations. We can verify if the data is available in the ProTherm or not. This is only available experimental database. So, we can compare whether this is comparable with the other mutations in the ProTherm database or not, right. This is what they use. There are many citations. Then also it is cited in very general applications, right, how we can use it for the biotechnological applications with the increase in stability. So, right, they are used the ProTherm database. There are several review articles also, they also in the books. So, they also cite the ProTherm. So, this will tell the how the ProTherm is important in this case. So, if you search the ProTherm citations, you will get this is the ProTherm version 4 is cited with 237 times, this is 54, this is 54, right. There are many citations, right. Okay, this is 283 citations, this is a ProTherm citations, right. Totally, if you add up all these 4 or 5 papers, right, so we get more than 1000 citations. Because earlier years nucleic acid research they published the updates of these in databases, right, not currently, earlier days. So, we have various updates, we have 4 or 5 updates. So, there is a reason we have the different updates, but each version we introduce new features as well as increase the number of data, right. So, this is the reason why it is. So, it is only used resource for protein stability. So, it is a good database and useful resource, right, for the protein researchers. These are other databases available in this bioinfo bank, so related with the ProTherm as well as other things. So, you can use the ProTherm database and get the information and have fun with this data and try to explore, right, more details and more insights about protein stability and relate with the functions or the diseases and that, right. Thank you.